In this video, we will learn how to find out the price that maximizes the total revenue of a firm given the demand function. The question is, a firm knows the demand function for its output is P is equal to 400 minus 0.5 Q. P denotes the market price, Q is the output. We have to find out the price that it should charge to maximize total revenue. Options are being given. We need to find out the correct option. Okay. So we have to maximize total revenue. Okay, so given the demand function, this is inverse demand function, P is equal to 400 minus 0.5. Can we write 0.5 is 1 upon 2Q? Okay, this is our inverse demand function. So let's first find out the total revenue first. So total revenue, as we know, it is equal to price into output, which will be equal to, so P is this very function 400 minus 1 upon 2Q. To this we multiply by Q, that gives us total revenue is. So multiplying Q to each of these terms, we get 400 Q minus 1 upon 2 Q square. This is our total revenue function. Okay, but we need to find out what will be the level of output first that maximizes the total revenue. Then we can find out the corresponding price. Okay, so let me write it here. So total revenue is maximized. When is total revenue maximized? Maximized when marginal revenue is equal to 0. That is to say, if I draw a simple graph here, and let me explain it here. So if we have output on the horizontal axis, total revenue on the vertical axis, if we have this total revenue function, this is our total revenue function. So total revenue is maximum where marginal revenue is equal to 0. What is the derivative of total revenue function with respect to output? That is the marginal revenue. Okay, so total revenue will be maximum when its slope is equal to 0. The slope of the total revenue function is in fact the marginal revenue. That means we need to find out the marginal revenue first. So what is marginal revenue? Marginal revenue is simply the change in the total revenue due to the change in the output. Okay, so the change in the revenue due to the change in the output gives us the marginal revenue. It means the derivative of the total revenue function with respect to Q. Derivative of Q will be 1. By power function rule, we will get only 400 minus, we have 1 upon 2. Derivative of Q square is 2 into Q, so we get 2 into Q. Why? Because we know from the power function rule of differentiation, derivative of x raised power n is simply n becomes coefficient. We have x and exponent is subtracted by 1. Likewise, let us say we have x raised power 4, its derivative with respect to x will be, so 4 becomes coefficient, then we have x and exponent is subtracted by 1, which becomes 4x cube. Likewise, I have done it here. 2 becomes coefficient and exponent is subtracted by 1, so 2 minus 1 in the exponent becomes 1, so we generally don't write the exponent as 1. Okay, so 2 gets cancelled. So total revenue is maximized when marginal revenue is equal to 0, so let's equate it to 0. Okay, solving, we get 400 minus Q is equal to 0, which implies Q is equal to 400. Okay, so our output is total revenue is maximized when we produce 400 units of output. Okay, now what will be the corresponding price that maximizes the total revenue? So price will be equal to plug the value of Q is equal to 400 in the inverse demand function. So we have 400 minus 1 upon 2. The value of Q is 400 here. So let's write it here, 400. So 2 1s are 2, 2s are. So we get P will be equal to 400 minus 200, which gives us 200 as the profit. Sorry, total total revenue maximizing price. Okay, the price that maximizes the total revenue is 200. That means option second should be correct. Okay, option first should be correct. That is this very what we call the option. Okay.